I want us to graph f of x equals to 2x divided by x minus 1 using our strategies of 7 steps that we talked about earlier. So the first thing I want to talk about is determining symmetry. So to determine symmetry, we will find f of negative x. If I replace every x with negative x, I get 2 times negative x divided by negative x minus 1. Therefore, I get negative 2x divided by negative x minus 1. Now, when I look at that problem, I see that I could simplify this more. I could take out a negative 1 in the denominator. If I go through and divide each one by negative 1, I end up with x plus 1 in the denominator. I have negative 2x in the numerator. The negative divided by negative becomes positive, so really I end up with 2x over x plus 1, which is not the same as the original. So since f of negative x does not equal to f of x, the graph has neither y-axis nor origin symmetry, because f of negative x does not equal to f of x, and f of negative x does not equal to the negative of f of x either. So therefore, I do not have y-axis symmetry nor origin symmetry. Okay? So step number 2. Let's determine the y-intercept. So to determine the y-intercept, I will replace x with 0. So plugging in 0 back into the original problem, I have 2 times 0 divided by 0 minus 1. Well, 2 times 0 is 0. 0 minus 1 is negative 1. Therefore, I get 0 divided by any number, 0. So therefore, your y-intercept is 0. So it's going to cross the origin. Step number 3. Let's find the x-intercept. Well, it stated in our rules before, to find the x-intercept, you will set p of x equal to 0 and solve. So p of x, remember, your numerator's p of x, your denominator's q of x. We'll set the numerator equal to 0. So if you set 2x equal to 0 and divide both sides by 2, x equals to 0. So there is your x-intercept. Step number 4, we will find the vertical asymptote. So your vertical asymptote, first thing you want to do is see if you can do any factoring, any crossing out. You cannot. So to find your vertical asymptote, take that denominator, set it equal to 0, add 1 to both sides. So your only vertical asymptote that you have is x equals to 1. Next, let's find the horizontal asymptote. To find your horizontal asymptote, you look at the degree in the numerator and the degree in the denominator. The degree in the numerator is 1, highest exponent of the variable. The degree in the denominator is also 1, the highest exponent of the variable. When they're the same, don't we set y equals to coefficient divided by coefficient? Well, coefficient in the numerator is 2. Coefficient of the variable in the denominator is 1. Therefore, y equals to 2 is your horizontal asymptote. Okay? So, and then we'll start plotting points, and we can find a few more points on this graph. So let's do that. Let's find a few more points on this problem here. I'm going to just use a table and find a few more points for us. Okay. If I plug in 2 into this problem, I would have 2 times 2 divided by 2 minus 1. So 2 times 2 is 4. 2 minus 1 is 1. Therefore, I get the point 2, 4 is also on this graph. I could plug in negative 2. Plugging negative 2 back into the original problem, I'd have 2 times negative 2 divided by negative 2 minus 1. Well, 2 times negative 2 is negative 4. Negative 2 minus 1 is negative 3. That would give me 4/3. So I have the point negative 2 4/3, or 1 1/3. I could also plug in negative 1 in the original problem. I'm just finding a few more points on my graph by picking x values, substituting them in for x, and solving for y. So 2 times negative 1 is negative 2. Negative 1 minus 2 is also negative 2. So negative 2 divided by negative 2 gives you positive 1. So there's another point. Negative 1, 1 is also on my graph. I'm going to pick one more. Let's pick positive 4. I'd have 2 times 4 divided by 4 minus 1. That's 2 times 4 is 8. Divided by 4 minus 1 is 3. So that's 8/3. So that would be the point 4 8/3. Okay? So I'm going to begin graphing now. Everything that I have and have determined about this graph. Okay? We know the y-intercept is the origin. That was one of the first things that we determined. We know the x-intercept was also x equals to 0. We have a vertical asymptote at x equals 1, so I'm going to go ahead and draw that vertical asymptote at x equals to 1. We don't have y-axis symmetry. We don't have origin symmetry. We determine that. We know we have a horizontal asymptote at y equals to 2. So here's my horizontal asymptote. This is y equals to 2. This is x equals to 1. Okay? And then we found some other points. Let's use those extra points. Negative 1, 1. So to the left, negative 1. Up 1. We found that point. We found the point negative 2 up 4/3, which is like 1 1/3. Okay. We found at positive 2, it's up 4. 1, 2, 3, 4. At positive 4, 1, 1, 2, 3, 4, we're up at 8/3. So that would be like 2 2/3. So at 1, 2, 3, 4, I'm up at 1, 2, 2 2/3 is somewhere about right there. Okay? So, what's actually happening is my graph looks something like this. It's getting closer and closer and closer to those vertical asymptotes and those horizontal asymptotes, but it's never touching it. So it looks something like this. So, we graphed this rational function by first looking into the symmetry, finding the y-intercept, the x-intercept, vertical asymptotes, horizontal asymptotes, and then we just plugged in a few points into the original equation to find some more distinct points so we could see exactly what this graph looked like.